Today we will going to conduct experiment on the compression test on any two metals like mild steel, brass, aluminum. So today we are going to conduct compressive test on the two specimen bar made up of material mild steel and aluminum. Industry expected outcome for this practical is to develop measurement skill and plotting the graph related to the compression test. And course level learning outcome for today's experiment is to analyze the structural behavior of the given structural components under the various loading conditions. And laboratory learning outcome of this experiment is to conduct compression test on the sample test specimen using compression testing machine. As various structural members and the various machine parts are subjected to the compressive load, so to identify the compressive strength of the material is a important factor. So our aim of today's experiment is to identify the compressive strength of the specimen. Now we will conduct compressive test on the universal testing machine. So this is UTM machine, and the main parts of UTM machine is this one is loading unit and this one is control unit. By using control unit we can give input to the test. Now from this we can select compressive type of test, and the material on which we are going to conduct the compressive test is, first we will take aluminum material. Now our specimen is cylindrical type and the diameter of specimen is 16 mm. We have entered all the values except the data and we will start the test. Now this setup is done. These are the standard specimen on which today we will going to conduct the compressive test. This is aluminum bar material having diameter 16 mm and length of bar is 48 mm. This is mild steel bar having diameter 16 mm and the length of bar is 48 mm. Take the specimen into the crossheads in between the middle crosshead and lower crosshead. And we will adjust the crosshead height. From this control unit, we can move the crosshead upward and downward direction. By using this downward arrow, we can move the crosshead in the lower side. Now I will close this valve and I will open this valve to act the load on the specimen. Applied compressive load, and because of this compressive load, length of bar is reduced and diameter of bar is increased. This is final specimen after the compressive strength. We can observe that diameter of bar is increased and length is decreased. We will conduct test, compressive test on the mild steel material by using same process. Now our test is compressive test. So material type is mild steel. and our material is cylindrical type and diameter of material is 16 mm. Now both the walls are closed and tear the load. Load tear. I will apply. Our specimen is set into the crosshead and from control unit I have tear the load. Now we will on the machine and gradually we are going to apply the load by opening this wall. From this screen we can observe that the value of applied load is increased and crosshead travel readings now indicate 0.050 mm. According to the application of load, crosshead travel will be increased. We are going to find out compressive strength of the mild steel material. Load is gradually applied on the member and we can see the observations will be started to bend. Now the wall is open and we can see the final reading on the screen. Maximum load applied on the mild steel material is 144 kilonewton and CHT travel we can observe that is 1.89 mm. And the compressive strength of this mild steel material is 716.49 Newton per mm square. Now this is final specimen after the compression test. We can observe the specimen after the compressive strength. The strength of mild steel material is more than the aluminium material and the observations. So moving towards the observations and calculations. This is observation table and we have conducted compressive test on the two specimen, that is first specimen is mild steel and second one is aluminium. The standard dimensions of the specimens are diameter of cylindrical bar is 16 mm and length of bar is 48 mm. We have calculated cross sectional area for both the bars and from the control unit we have observed the peak load before failure of the specimen. For mild steel material, the peak load is observed as 144.06 kilonewton. Here we have converted into the Newton, means multiply by 10 raised to 3. And from the standard equation of stress, compressive strength sigma is equal to P by A, load upon area. We have calculated the compressive strength of the mild steel bar. And the compressive strength of mild steel bar is 716.50 Newton per mm square. In the same way, we have calculated compressive strength of the aluminium bar. Peak load is 107 kilonewton and the compressive strength is load upon area. That means compressive strength is 532.17 Newton per mm square. The compressive strength of mild steel is greater than the aluminium material. So this is all about the compression test on the different specimens. Thank you.